In 2006, the scientific community did something that felt like a personal betrayal to an entire generation. We took away Pluto's status as a planet. We relegated it to the status of a dwarf, a cold, lonely misfit at the edge of the map. We assumed it was just a dead, frozen relic, too small and too far away to be important. At the time, we thought we knew the outer solar system, a dark, stagnant graveyard of ice where nothing ever changed. For 9 years, Pluto remained a mystery, a tiny, pixelated blur even in our most powerful telescopes. But in July 2015, after a 3 billion-mile journey that took nearly a decade, NASA's New Horizons spacecraft finally reached that distant shore. What it found wasn't a dead rock. It was a world that was active, vibrant, and more geologically alive than almost anything else in our solar system. Pluto didn't just meet our expectations, it shattered them. This is the story of how the underdog of the solar system proved the world wrong. When the first high-resolution images beamed back to Earth, the mission team was speechless. They expected to see a cosmic graveyard covered in craters from billions of years of asteroid impacts. Instead, they saw Sputnik Planitia. This massive heart-shaped glacier, larger than Texas, is remarkably smooth. In a solar system where every moon and planet bears the scars of cosmic bombardment, this region has 0 visible craters. In geological terms, this surface was resurfaced yesterday, likely within the last 100 million years. But here's the problem. Pluto is 3 billion miles from the Sun. It's tiny, only 2/3 the size of our moon. By every law of planetary physics, its core should have frozen solid billions of years ago. It shouldn't have the energy to erase its own craters. Finding this was like finding a warm, running engine in a car that's been abandoned in a blizzard since the 1950s. As New Horizons zoomed closer, it revealed the secret behind Pluto's youth: polygonal convection. The surface of that icy heart is divided into giant cells, 10 to 30 miles across. Imagine a giant, slow-motion pot of boiling soup. But on Pluto, the soup is solid nitrogen ice. Because nitrogen ice is soft and malleable even at -400 degrees Fahrenheit, the internal heat from deep within Pluto causes it to warm up, rise to the surface, cool down, and sink back again. This glacial churning is a geological heartbeat, constantly refreshing the surface and swallowing any asteroid impacts. But this creates a massive scientific paradox. Where is the heat coming from? Pluto doesn't have a giant planet like Jupiter nearby to tug on it and create tidal friction. Scientists now believe it might be radiogenic heat, the slow decay of radioactive elements in its rocky core. But even that shouldn't be enough. Pluto is hiding an energy source we still don't fully understand. To the east of the heart, New Horizons found bladed terrain, skyscraper-sized shards of methane ice hundreds of feet tall. These sharp, jagged ridges form through a process called sublimation, where ice turns directly into gas, carving out structures that look like giant dragon scales from orbit. These penitentes are found on Earth, but only at a few inches high. On Pluto, they reach 1,600 feet. And then there is Pluto's largest moon, Charon. Charon is so massive, nearly half the size of Pluto, that the two are locked in a binary embrace. Unlike our moon, which orbits around Earth, Pluto and Charon actually orbit a point in empty space between them. But it's the shape of this dance that is truly bizarre. While most moons orbit in neat circles, Pluto's smaller moons, Styx, Nix, Kerberos, and Hydra, live in a world of gravitational chaos. Because Charon orbits Pluto in an off-center, oval-like path, its gravity acts like a giant blender, constantly stirring the smaller moons. This causes the smaller moons to spin wildly. While our moon always shows one face to Earth, Pluto's smaller moons tumble and flip unpredictably. They don't have a stable north pole. They are spinning tops in a chaotic gravitational field. This oval dance creates a dynamic system that is more like a mini solar system than a simple planet and moon. Scientists discovered that Pluto is actually painting its moon. Methane gas escapes Pluto's atmosphere, drifts through space, and gets trapped by Charon's gravity at its north pole, nicknamed Mordor Macula. There, solar radiation turns that gas into a deep, rust-red stain. It is a cosmic dance of chemistry, occurring across a vacuum. But there is a tragedy hidden in this beauty. Pluto's atmosphere is a seasonal miracle. Because Pluto's orbit is egg-shaped, it spends decades moving further and further away from the Sun. Scientists realized that New Horizons arrived just in time. As Pluto moves toward its furthest point from the Sun, the temperatures drop so low that the atmosphere literally collapses. The nitrogen gas turns into snow and falls to the ground, leaving the planet in a vacuum hibernation for decades. We caught Pluto during its brief summer. If we had sent New Horizons 20 years later, we would have found a world with no blue ring and no breathing atmosphere. The most staggering discovery wasn't found on the surface, but hidden in Pluto's wobble. When scientists modeled how the Heavy Heart Glacier aligned itself, the math only worked if there was something incredibly dense beneath the crust. The answer? A global liquid water ocean 100 miles deep. How can liquid water exist at minus 400 degrees? The secret is a toxic cocktail. To keep this water from freezing, it must be a thick, salty syrup loaded with ammonia. On Earth, ammonia is a cleaning chemical. On Pluto, it's a life-saving antifreeze. This ammonia lowers the freezing point of water and keeps the ocean in a slushy state. Pluto isn't just holding on to this water, it's spewing it out. We found Right Mons, a mountain 90 miles across and 2.5 miles high. This is a cryovolcano. Instead of molten lava, it erupts with ice magma, a mixture of water ice and ammonia that flows like toothpaste. The fact that Right Mons is so massive and lacks craters suggests that Pluto's internal heat engine is still running today, pushing liquid from the deep interior up to the surface. When it came time to name these lands, the team turned to the explorers of the unknown. They named features after underworld deities like Cthulhu and Mengpo, but they also honored the pioneers of Earth. The icy peaks were named the Hillary Montes and the Tenzing Montes after the first men to summit Everest. It's a fitting tribute. The highest mountains on Earth and the icy mountains at the edge of the solar system both stand as monuments to human curiosity. We bring our stories with us, no matter how far we travel into the dark. We stripped Pluto of its title, but it gave us a miracle in return. It proved that our definitions are often too small for the reality of the universe. If a dwarf planet can maintain an ocean, an atmosphere, and active volcanoes, then life can exist anywhere, even in the coldest corners of the cosmos. Pluto may be small, but it's a giant in every way that matters. It's not just a collection of rocks. It's a vibrant, living world that was simply waiting for us to catch up. The next time you look at the stars, remember the little world that refused to stay dead. The universe is alive, and it's waiting for us to listen.